right, 37. We know this is a positive cubic, so we know that the arrows would go over here and here. So I guess that allows us to do the end behavior. Okay, before we even get started, we can set up this template. And we know that if we go to the negative infinity, as x does, that would be negative infinity as well, but then it goes to positive infinity as we go to the right. Okay, so the domain here, again, will be all real numbers. That's the great thing about polynomials, is that the domain is always real numbers, it's all continuous. Now the range actually is going to be the same thing, because notice here we had an issue because we know they're both going down. We didn't know how high, but this guy is going to span the whole, the entire graph. So it doesn't matter what happens in here, the end behavior will make sure that our range is all real numbers. Now we don't know what's happening in between, so that's what we're going to have to figure out, and we're going to use the graphing calculator. Now I know that we could figure out zeros, like we could do that using other methods, like all this stuff, but we're not going to have to. Okay, for this stuff, I would want you to use the graphing calculator. So let's go ahead and do that. We're going to go to y equals, clear that out, and now we've got a x to the third power, and then minus 3x to the second power, and then plus 6. We'll do a zoom standard. Okay, and we'll take a look at this guy here. Looks like we only have one x-intercept, and so we'll go to second calc. That's called a 0. The x-intercept is a 0, so we will set the left bound, and there's the right bound. The guess is about there, and correct. Looks like it's about negative 1.19. Okay, negative 1.19. So I guess we could go 2, but that's okay. This is just fine. X-intercept there. That's the only one, so it only has one real 0. These other two would be imaginary. Now the y-intercept is right there, so let's see if we can count. Yes, we can. 1, 2, 3, 4, 5, 6. Looks like it's at 0, 6. Okay. Relative min. Now, a relative min is right there. That's actually at 2, 2. That's actually easy to see. And then the relative max actually happens at 0, 6. Oh, this is great. Okay. So now for our increasing and decreasing intervals, this is a lot easier than this guy. Our increasing interval would be from negative infinity up to 0. Okay. Then it stops. Then at 0 is where it decreases, and then goes down to 2, and then up here, 2 goes to positive infinity. So notice that wherever this skips over, he fills in that gap, because if he's not increasing, he's decreasing, as long as there's not a constant flat line. Okay, so yeah, that's all set. Next, this guy right here, it looks like we've got some factoring to do, and so it looks like we've got some zeros that we want to find out. We've got a multiplicity and the effect. And so the effect, we can use words like bounce, brush, and cross. Okay, that's totally fine. So let's go ahead and then see what we can do to factor. It looks like we can take out an x. So x squared plus 10x plus 25 actually equals, I can have a 5 and a 5. Well, factors of 25 that give me 10 is 5 and 5. So it looks like I got x, and then x plus 5 quantity squared. So we got a 0 at 0, and then a 0 at negative 5. The multiplicity here is 1. The multiplicity here is 2. So this would be a cross, and this would be a bounce. Okay. All right. Over here, this guy looks like we're going to have to do some grouping, so split it down the middle. That's all we got, really. Or we'd have to use a rational root theorem, but with this topic right here, we actually don't have that skill yet. So we're going to take out an x squared, and then we would have x plus 2. Here we take out a negative 1, so, nope, negative 4, so that we'd have an x plus 2. There we go. So our factored form is almost finished here. X squared minus 4, difference of 2 squares, and then an x plus 2. That's great. So our factored form then is f of x equals x minus 2, x plus 2, but notice that I've got one there and then I got another one here, so there's two of them. So I've got a 0 at 2 and I've got one at negative 2. I don't care what order you put those in. At 2, he is a multiplicity of 1, but he's got a multiplicity of 2 there. This is a cross through, okay? Or this is sometimes just said intersects, intersect, intersect. There we go, that's why I couldn't spell it. And then this guy is, if it's a bounce, sometimes they'll just call it a tangent line, okay? But it doesn't matter, okay? You would just be using English anyway. Okay, all right, so what is left? Got the last page here. I think we'll do these, the remainder theorem, and then we'll go ahead and do the last video. The remainder theorem is just evaluating a particular number in a polynomial, and this is meant to be a shortcut. So if you're going to use synthetic division, you want to make sure, now remember, the remainder theorem is synthetic division, so is the factor theorem. So we're going to have 4, 3, 2, 1, 0. They're all in order, so we do not have any holes. We can just put these guys in order. Okay, we drop it. Negative 6, negative 8, negative 16. That's going to be negative 22. That's going to be a positive 44. That's going to be a 51. 51 times 2 is 102. And that's going to give us a negative 111. And of course, it's completely wrong. What did I do here? 6. Of course, I totally screwed up. Oh, yeah, of course. Jeez, oh, Pete. It should be positive 16. And then that should be 6. And then negative 12. And then that would be, nope, I'm sorry, negative, oh, no, what am I doing? 10. Oh, my gosh. It's embarrassing. I'm not going to edit it out, though. What is that, negative 13? Yeah, negative 13, and then negative 26, for God's sake. And then if that's 9, then that should be negative, but that would be, oh, double negative. So, oh my gosh, I'm really ruining this one. 6 and 317. Okay, whew. Wow. Okay, that's actually embarrassing. I'll live with it, though. We got a 5th degree polynomial. Definitely, we only got 4 terms, so we definitely got some holes here. So it looks like I'm missing a degree at 4. I have one for 3. I'm missing one at 2. I have one for 1, and then I got the 21. Okay, so let's drop this. I'm going to be a lot more careful now. Negative 1, negative 3, add negative 3, multiply negative 9, add negative 2, multiply negative 6, add negative 6, negative 18. Okay, double check that in case it goes to 0. Nope. Okay, so that's negative 36. And negative 36 times 3, that would be 18, carry the 1, that would be negative 108. And then adding those two together, so you take away 8 from here to be 7, I'm getting negative 87. Okay, yep. All right, negative 87. Okay, where are we at? 9-minute mark. You know what? Let's do factor theorem. It's an easy one. We are just going to determine if that goes into this evenly. Okay, do these guys go into these evenly? And honestly, you just, it's synthetic division, and as long as you don't do this kind of crap up here, everything's good. But you know what? Actually, we could have kind of stopped right here if you notice the numbers are getting larger, because with the factor theorem, if they're not kind of like staying close together, like you know that they're going to shoot off to like really a large negative or a large positive number, then you know that it can't be a factor. So 1, that's 5, and then that's 5, so negative 2. Now I can stop right there because I needed a positive 10 here in order for it to be a factor. And so our just answer is no, it's not a factor. Okay. Over here, I'm going to put -2. Now, do notice, though, the factor theorem requires me to change the sign because I need to know if it equals 0. Here, I literally plug in exactly the value that I'm interested in plugging in. So make sure that that's very clear. Don't forget that. 3, 2, -20, -8, and 32. Okay, so drop the 3, -6, that's -4, that's +8. That would give me -12, that's going to give me 24. So then that guy is +16, so that would give me -32, and there we go. The answer is yes, it is a factor. So if my test might ask me this, okay, this is what I've proven. Okay, I've proven that these two multiplied to each other actually equal this. Okay, all right, we'll stop there and make the last video.